Hello, my name is Karishma Changlani, and I will be demonstrating Pentago, that an application that I created to simulate that game. It will be a strategy game. I will put in the instructions on the abstract on how the game is played. This is an AI based game, so it will be only one user versus the computer. And let's go. So it's a basic Python 3 app that I created. It's the GitHub repository's link is also in the abstract if you wanted to look at the code. I start with the prompt of do you wish to be a player? One or player two. All this means is that whether you would have the first go or the second go. Like usually we have a chess or checkers. In this game, I'll decide to be player one. Um, let's say my name is Karishma, that is my name, and I will name the player 2, which is the computer, which will be the AI that I'll be playing against. That's the current grid. It's a basic console app, so the console graphics are very limited. It's just basic, 256 colors and just your basic graphic printed text from Python. And I will make my move. There's a specific format for the move that I have included in my README for those who want to use this app. 1/R basically 3 basically means that I'll be putting a piece on the first square's third block, and I'll be rotating it the first square towards the left. So as you see, it produced and it did what I expected it to do, and it moved towards left after putting it on 3, and then it made its own move, which happens to be 1 2 1 L. Let's make another move to further demonstrate how this works. You can move any square and you can put your piece at any unoccupied space. If you put it in a space that's already occupied, the computer ignores your move and you don't get to put a piece on the board. We move forward. From now I skipped ahead a little bit to kind of continue the same motion of movements. I make moves, the AI makes moves, and so on and so forth. As you can see, I made a move and then so did the AI, and so on and so forth until one of us came forward. Now, since I know my artificial intelligence and what sort of decisions it make, I was able to outwit it and kind of win the game in the final move. But yep, there you go. It can detect the winds and it can kind of make its own judgment, and it does try to hinder a lot of times your moves. So there we go. I basically used maximizing and minimizing technique and alpha beta pruning on standard binary decision trees to determine what decision the artificial intelligence should make when going forward. It's a pretty weak AI and it's highly based on predictable patterns. It's not a self-learning mechanism, and it definitely doesn't improve with time. It's not a machine learning algorithm, but it's something I would like to program for this particular application because I definitely enjoyed this a lot, and I would really look forward to working more on systems like these. Thank you.